Introducing Space Drums, the open source air drums. This virtual drum kit contains hi-hat, snare, floor tom, kick drum, and crash. I came across this reel on Instagram and the kid inside me screamed, "You have to make one of those." Of course, I had no clue how many headaches were waiting for me. The initial plan was simple. Use an IMU motion sensor to track the speed and angle of my hits, wire it to an ESP32 microcontroller to act as the brain, and power it with a lithium-ion battery. Take 2 of these setups and shove them into some plastic pipes. I jumped into Easy EDA to map out the circuit. But hand wiring all this would be a nightmare, so I exported the design files and sent them off for manufacturing. A few weeks later, the assembled PCBs arrived, courtesy of today's sponsor Next PCB. Next PCB manufactures professional quality PCBs for projects like this. Next PCB is the international service from HQ Electronics, a company that's been helping engineers build PCBs for over 15 years. They offer fast PCB manufacturing and assembly with a really convenient online quotation system, so you can upload your design and quickly get into production. If you want to turn your own crazy ideas into actual hardware without the headache, check out Next PCB at the link in the description. When I first tested the PCB, there were many issues because I made some rookie mistakes while designing it. But with a few fixes, I soon got the accelerometer working. But motion tracking was a whole different story. You see, I initially thought the accelerometer would detect the physical hits and the gyroscope would detect the orientation to map out where the virtual drums were. Hit detection was great, but the orientation was a disaster because of gyroscope drift. The sensors basically get confused over time, meaning the entire virtual drum kit would slowly rotate around while I played. After some research, which I should have done before designing the circuit, I realized my IMU lacked a magnetometer, basically a digital compass. Without it, the sticks couldn't lock onto the Earth's magnetic field to figure out which way was forward. But judging by the reviews of commercial air drumming products, it turns out that even with a magnetometer, this method of virtual tracking isn't very reliable. After weeks of trying out different methods to fix this, I realized we might not need any additional components. We could use the most powerful device we all already own. The plan was to use computer vision to track the position of my arms to detect which virtual drum each wrist was hovering over. After some programming and testing on my laptop, I finally had it working. I made a smartphone version of the PC application so that I would not have to carry a whole laptop to play. Now it was time to assemble everything and make it look like real drumsticks. I soldered all the connections and fit the whole circuit into a 1-inch diameter PVC pipe. Then I covered the pipe with a wood finish vinyl wrap. For the bass drum, I used an extra PCB from the sticks and programmed it to detect taps on the floor. Slide it into your right shoe and you have an instant bass pedal. To power on the drumsticks, we first press the power switch on each stick. To charge the battery, plug in a USB-C cable from a standard 5-volt power supply. Hold the sticks parallel, pointing at the snare for 10 seconds right after power up for calibration. Then you can start playing. Hi-hat on the left, snare in the center, floor tom on the right, ride on top right, crash on top left, and the bass drum is on the foot pedal. Honestly, I think it's a lot of fun playing drums with this thing. While it is not as portable as I initially planned because of having to set up a tripod for the smartphone, it is still way easier to carry this around compared to a regular drum kit. Now you might wonder, why not just use the camera for everything and play with regular wooden sticks? One word: latency. The camera takes a split second for the AI to process the video. If you hit a drum and hear the sound half a second later, it's unplayable. But the custom PCBs act like pure reflexes. The hit detection is basically instant. And before the real drummers rush to the comments to say how it would never feel or sound like a real drum kit, I totally agree with you. But for someone who just wants to explore playing drums out of curiosity or casually jam with friends, this is a perfect device. In fact, it might lead to more people buying real drum kits after realizing how fun drumming can be. The project is fully open source and all codes, circuits and files needed to set this up can be found on my GitHub repo linked in the description. If you like this DIY project, you're going to love what I built in my previous video right here. Check it out and I'll see you there.